Okay, a grade 12 applied. This is lesson 4 of the probability unit. So we're going to talk about conditional probability. So let's start off with some definitions here. Dependent events are events whose outcomes are affected by each other. That's why they depend upon each other, right? Dependent events. Conditional probability is the probability of an event occurring given that the other event has already happened. So here's the formula for conditional probability. So probability of A and B equals probability of A times the probability of B slash A. Well, what the heck does that mean? Well, that means the B slash A is the probability of B given A has already happened. Now, we often do this with tree diagrams, or you could use, well, tree diagrams are probably the easiest way. Let's look at example 1 here. So Nathan draws a number between 1 and 40. He says that his number is a multiple of 4, right? So here's the big listing. So A multiple of 4, 4, 8, 12, 16, 20, right? We're going up by 4s every time, all the way up to 40. Determine the probability that the number is also a multiple of 6. So B multiple of 6, 6, 12, 18, 24, 30. Yeah. So you can see, and if you look, we've circled here all the ones that are the similar for both, right? 12, 24, 24, 36, and 36. So probability of A and B equals the probability of A times the probability of B slash A. So what we have here is we know the probability of A and B. That's 3 out of 40. We know the probability of A, multiples of 4. We can just count them up and we can see that it's 10. What we're looking for is this last part here, probability of A slash B. Okay, well, how do we solve for that? That's like an unknown variable. So to get rid of this, you divide both sides by 10 over 40. Yeah, we know when we divide, we multiply by the reciprocal, so 40 over 10. The 40 is reduced down and we end up with 3 over 10. So the probability, oh, well, here, let's go to the therefore here, 3 over 10, right? Or 30% chance the number is also a multiple of 6. So this is another question where we work backwards through the formula to figure out what the answer is. Okay, flip the page, let's go to example 2. According to a survey, 91% of Canadians own a cell phone. Of these people, 42% have a smartphone. Determine the probability that anyone you meet will have a smartphone. So we had to correct some of the spelling here. It's a little backwards here. So A, cell phone, B, smartphone. So the probability of A and B, again, we use that same formula as before. So the probability of A, 91% of Canadians right there have a cell phone. So 0.91, we did it as a decimal. Of these people, 42% have a smartphone. So there's our 42%, because you have to have a cell phone first, and then you can determine if it's a smartphone, right? So that's the probability of A and B there. So then all we do is multiply those together. We end up with 0.38. We end up with 38%. That's one way. Now, if you don't like that way, try it with a tree diagram. So what we have here is cell, no cell, right? So cell, 91%. No cell, 9%, right? Because it has to total up to 100%. Of that cell phone, 42, right, have 42 have a smartphone. Well, how do we figure out this 58? Well, 42 and 58 still has to be 100%. Okay, and then all you do is you multiply 0.91 times 0.42. That gives us our 0.38. 0.58 gives us that, and you can even look at the no cell phone down here. So again, we can look at, oh yeah, this is the one we want, 0.38, which is 38%. Okay, example 3. So based on the school's ultimate Frisbee team record, there's a 60% chance of winning on a calm day and 70% chance of winning on a windy day. They're a pretty good percentage either day. So tomorrow there's a 40% chance of high wins. There are now ties in ultimate. So what is the probability that the team will win tomorrow? We got to look at this. So we have calm and windy, right? So if it's windy percent 40, it's going to be calm 60. And then if we do calm, we can look at, hey, they have a chance of winning if it's calm, 60%. That's from the question. So obviously this W prime, like this thing here, it means a not, right? So if it's win, then that would be the same as a loss. So we could write it as a W that, or you could just write it as a loss if you want. And those two add up to 100%. If it's windy, the chance that they win is 70%, and the chance that they don't win is 30%. So then we can do is just multiply across. So calm, calm and windy, multiply those two, we end up with 0.36. Calm and loss, or not a win, 24. A windy and a win, 28. Windy and a loss or not a win is 12. The ones we're looking for is, if you look, what is the probability the team will win tomorrow? So you have to look at where the wins are. So the wins are right there and right there. So we take the two of them, 0.36 and 0.28, and we add them together, so 0.64. There's a 64% chance they will win. So that's based on a tree diagram. Okay, so that is the last lesson of this unit. Look for more stuff coming up.